In this video, we'll be looking at some extra examples for 6.1. So in this lesson, we're just trying to simplify some square roots. So we're just going to do a bunch of those, just trying to get this process down. So number one, let's look at the square root of 8. So the problem's given to us like this, and then we just go through this process. So the first thing I want to do is build my factor tree. So I'll write 8 off to the side. And when I'm writing down the factors, I'm writing down numbers that multiply to equal 8. So I can say, well, 4 times 2 equals 8. 4 times 2 equals 8. So now I'm going to break 2 down into its factors. Well, 2 has 2 times 2 is 4. Now, once we can't factor anymore, we stop. And what I mean by that is we do not want to do 2 times 1. We do not want to do that because there's no value. I could just go on forever. 2 times 1, 2 times 1, 2 times 1. So we'll just stop right there. This is where we're stopped. Now we're looking for pairs. Well, first, let's write our square root symbol for our answer. This is where my answer is going to be, right here. Anytime there's a pair, that's a pair of 2's right there, I'm going to put that out front. And then any number by itself will go on the inside. If there were multiple numbers out front, we'd multiply, and the same with the inside. But since there aren't, we just have 2 root 2. We box it, and we're done. Like so. So let's do another one. Say we're doing the square roots of 54. Well, we'll start by first writing our number 54 and creating that factor tree. So 54 can be 6 times 9. Then 6 breaks down to 3 and 2. And 9 breaks down to 3 times 3. The factors of 3 are just 3 times 1, so I don't want to break it down any further. 2 is 2 times 1, that's all we have, so don't break it down. Same with these 3's. Okay, so I'm going to write my square root symbol. I'm writing my answer right now. So anywhere there's a pair, I see a pair of 3's, so I'll put that out front. Any number that's left by itself, if there's just a single one, we'll write it underneath, and then we multiply all those numbers together. So that 3 stays a 3 on the outside, and then I have my square root symbol, and on the inside, 3 times 2 becomes 6. Okay, so let's look at another example. Let's do the square root of 108. So if we look at 108 off to the side, we can start breaking it down. Well, 108 breaks down into 9 times 12. The 9 can break down into 3 times 3. 12 can break down to 3 times 4, and 4 breaks down to 2 times 2. Now, anywhere there's a pair, we pop it out front. So, and I go to the end of my line. So I see they end right here, so that's a pair of 3's. I write my square root symbol for my answer. So a 3 comes out front. There was a pair of 3's, so a 3 came out front. There's a pair of 2's, so I'm going to put times 2 out front. Now I have this singular, if I follow this trail, it ends right here with that 3, so I got to keep track of that 3. So that singular 3 goes inside. And now we'll have 6 square root 30. 2 times 3 is 6. And this has nothing else to multiply on the inside, so it stays the same. Okay, let's do one more. So say we were doing the square roots. The square root of let's try 84 and see what happens. So when I look at 84, we'll write our number down and we'll start creating our factor tree. Well, 84 is an even number, so I'll start by saying, well, 2 times 42. And then 42 can break down to 6 times 7. And 6 can break down to 2 times 3. So we're going to write our square root symbol. We're building our answer. I'm looking for a pair at the end of my line. So I have a 2 there, 2, 3, and 7. So these are the ends of my line. I have a pair of 2's right here. There's a pair of 2's, so we can put that out front. So we took care of that pair of 2's. Now I have this 3 and this 7. They don't have pairs, so we'll leave them by themselves, like so. Now there's the 2's by itself on the outside, so it stays the same. And then we multiply the 3 and the 7 together to get 21. So there's some extra examples on how we can simplify square roots. We're just building our factor trees, looking for pairs to pop out front, and any number that's by itself goes back on the inside of the radical. So thank you very much for watching this video, and I hope you have a great rest of your day.